Upsizing wire to number 10 for a refrigerator can indeed save money over time. This is primarily due to reduced energy loss. Number 10 wire presents a lower resistance compared to number 12 wire. Consequently, as electricity flows through it, less energy is dissipated. This diminished energy dissipation directly translates into lower electricity bills over the lifespan of the refrigerator. The reduced energy loss also leads to cooler operating temperatures for the refrigerator's wiring. Cooler wires contribute to a longer lifespan for the appliance itself and can improve its overall energy efficiency. An overloaded circuit will cost more to operate even if the appliances connected to it are functioning correctly. Overloaded circuits experience increased resistance. When a circuit is carrying more current than it is designed to handle, the wires heat up. This increased resistance wastes energy as heat. This wasted energy results in higher electricity bills. An overloaded circuit can also create a safety hazard. The excessive heat generated by overloaded wiring can cause insulation to melt, leading to short circuits or even electrical fires. Therefore, it is crucial to avoid overloading circuits to protect both your wallet and your safety. In conclusion, upsizing the wire to number 10 for a refrigerator presents an opportunity to save money through reduced energy loss and potential improvements in appliance lifespan. Conversely, operating an overloaded circuit incurs higher operational costs and introduces significant safety risks. To reiterate the advantages of upsizing wire, consider the principles of electrical resistance and power loss. Electrical resistance is the opposition to the flow of electric current in a circuit. All conductors have some level of resistance, but thicker wires like number 10 have a lower resistance per unit length than thinner wires like number 12. When electricity flows through a wire with resistance, some of the electrical energy is converted into heat energy. This is known as resistive heating or joule heating. The amount of power lost as heat is proportional to the square of the current flowing through the wire and the resistance of the wire. Following the formula, power equals current squared times resistance, or P equals I squared R. Therefore, even a small reduction in resistance can lead to a significant reduction in power loss, especially when the current is relatively high, as it is with a refrigerator. Now let's delve deeper into the effects of cooler operating temperatures. When wires operate at cooler temperatures, several benefits arise. Firstly, the insulation surrounding the wires degrades more slowly. Heat accelerates the breakdown of insulation, which can lead to shorts and other electrical problems. By reducing the operating temperature, the insulation remains intact for a longer period, reducing the risk of failures and the need for repairs. Secondly, cooler temperatures improve the efficiency of the refrigerator itself. Refrigerators work by transferring heat from the inside of the appliance to the outside. When the wiring and other components are cooler, it is easier for the refrigerator to dissipate heat, resulting in a more efficient cooling process. This can translate into lower energy consumption and further cost savings. Thirdly, the lifespan of the refrigerator's components can be extended. Excessive heat can damage electronic components and reduce their lifespan. By keeping the wiring and other components cooler, the refrigerator is likely to last longer, reducing the need for replacement and saving you money in the long run. To elaborate on overloaded circuits, it's crucial to understand the concept of ampacity. Ampacity refers to the maximum amount of electric current a conductor can carry continuously without exceeding its temperature rating. Wires are designed to handle a specific amount of current safely, and exceeding this limit can lead to overheating and other problems. When a circuit is overloaded, the current flowing through the wires exceeds their ampacity. This causes the wires to heat up, increasing their resistance and wasting energy as heat. The increased resistance also reduces the voltage available to the appliances connected to the circuit, which can affect their performance. In severe cases, an overloaded circuit can cause the insulation to melt, creating a fire hazard. Now let's examine the potential for overheating and fire in greater detail. Overheating is a serious concern with overloaded circuits. When wires overheat, they can ignite nearby combustible materials such as wood, paper, or fabric. This can quickly lead to a fire that spreads throughout the building. Even if a fire doesn't occur, overheating can still damage the wiring and other electrical components, requiring costly repairs. To prevent overheating and fire, it's essential to avoid overloading circuits. This can be achieved by distributing appliances across multiple circuits, using extension cords sparingly, and avoiding the use of multi-outlet adapters that allow you to plug too many devices into a single outlet. Furthermore, it's crucial to have a qualified electrician inspect your electrical system regularly to identify any potential problems and ensure that your wiring is up to code. Let's look at some examples of how upsizing wire can save money in real-world scenarios. Imagine a refrigerator that draws 5 amps of current and operates for 24 hours a day. If the refrigerator is wired with number 12 wire, the resistance of the wire might be 1.588 ohms per 1000 feet. If the refrigerator is located 50 feet from the electrical panel, the total length of the wire run is 100 feet, and the resistance of the wire is 0.1588 ohms. The power loss in the wire is calculated as power equals current squared times resistance, or P equals 5 squared times 0.1588, which equals 3.97 watts. Over a year, this translates to 3.97 watts times 24 hours a day times 365 days a year, which equals 34.7 kilowatt hours. At a rate of 15 cents per kilowatt hour, the cost of the power loss is $5.21 per year. Now, let's consider the same refrigerator wired with number 10 wire. The resistance of number 10 wire is 0.9989 ohms per 1000 feet. For a 50-foot run, the resistance is 0.9989 ohms. The power loss in the wire is calculated as P equals 5 squared times 0.9989, which equals 2.50 watts. Over a year, this translates to 2.50 watts times 24 hours a day times 365 days a year, which equals 21.9 kilowatt hours. At a rate of 15 cents per kilowatt hour, the cost of the power loss is $3.29 per year. In this scenario, upsizing the wire from number 12 to number 10 saves $1.92 per year. While this may seem like a small amount, it can add up over the lifespan of the refrigerator. Furthermore, the savings would be even greater for appliances that draw more current or operate for longer periods. Now let's delve into the economic consequences of overloaded circuits. Imagine a circuit that is designed to handle 15 amps of current, but is being used to power appliances that draw a total of 20 amps. This circuit is overloaded by 5 amps. The excess current causes the wires to heat up, increasing their resistance. The increased resistance wastes energy as heat, resulting in higher electricity bills. Furthermore, the overheating can damage the wiring and other electrical components, requiring costly repairs. In severe cases, the overheating can cause a fire, which can result in significant property damage and even injuries. To avoid these economic consequences, it's essential to avoid overloading circuits. This can be achieved by distributing appliances across multiple circuits, using extension cords sparingly, and avoiding the use of multi-outlet adapters. It's also important to have a qualified electrician inspect your electrical system regularly to identify any potential problems and ensure that your wiring is up to code. Now let's explore the safety implications of overloading circuits. Overloading circuits poses a significant safety hazard, as it can lead to overheating and fire. When wires overheat, they can ignite nearby combustible materials such as wood, paper, or fabric. This can quickly lead to a fire that spreads throughout the building. Even if a fire doesn't occur, overheating can still damage the wiring and other electrical components, creating a risk of electric shock. Furthermore, overloading circuits can trip circuit breakers or blow fuses. While this is a safety mechanism designed to protect the wiring from overheating, it can also be inconvenient and disruptive. In some cases, repeated tripping of circuit breakers or blowing of fuses can indicate a more serious underlying problem with the electrical system. To ensure electrical safety, it's essential to avoid overloading circuits. This can be achieved by following the guidelines mentioned earlier, such as distributing appliances across multiple circuits and using extension cords sparingly. It's also important to have a qualified electrician inspect your electrical system regularly to identify any potential problems and ensure that your wiring is up to code. Now let's delve deeper into the National Electrical Code, or NEC, and its relevance to wire sizing and circuit protection. The NEC is a comprehensive set of standards for electrical wiring and equipment in the United States. It provides guidelines for safe and reliable electrical installations. The NEC specifies the minimum wire size required for different types of circuits based on the ampacity of the circuit and the type of insulation used on the wire. The NEC also specifies the type and size of overcurrent protection devices, such as circuit breakers and fuses, that are required to protect the wiring from overheating and fire. When upsizing wire, it's essential to comply with the NEC. This ensures that the wiring is adequate for the intended load and that the overcurrent protection devices are properly sized to protect the wiring from damage. The NEC also provides guidelines for directing wire ampacity in certain situations, such as when multiple conductors are bundled together or when wires are installed in hot environments. Directing reduces the ampacity of the wire to account for the increased heat generated by the conductors. To ensure compliance with the NEC, it's always best to consult with a qualified electrician. An electrician can assess your electrical needs, determine the appropriate wire size and overcurrent protection devices, and ensure that the installation meets all applicable codes and standards. In addition to the NEC, there may be local codes and regulations that govern electrical installations. These codes may be more stringent than the NEC and may require additional safety measures. It's important to be aware of these local codes and regulations and to comply with them when installing or modifying electrical wiring. To summarize, upsizing wire to number 10 for a refrigerator can save money by reducing energy loss and improving appliance lifespan. Overloaded circuits, on the other hand, cost more to operate and pose a significant safety hazard. To ensure electrical safety and efficiency, it's essential to avoid overloading circuits, use the appropriate wire size for the intended load, and comply with all applicable codes and standards. Remember to consult with a qualified electrician for any electrical work to ensure that it is done safely and correctly.